This is the video for the gas laws unit problems about ideal gas law problems with molar mass. This first question is a review of how to find moles given a number of grams of a substance. It says a sample of oxygen gas contains 90.9 grams of O2. How many moles of O2 are in the sample? Well, we know that there are 90.9 grams of O2, and we're looking for number of moles. There's something we need to know to do this conversion. We need to look on the periodic table and find the number of grams in 1 mole of oxygen. That's called the molar mass. 1 mole of O2 equals 32 grams O2. On the periodic table, oxygen has the number 16 in its box, and that's the number of grams in 1 mole of O. Remember, this is O2, so it's 16 times 2 to get 32 grams. So we're going to take our given 90.9 grams, and we're going to set it up in this conversion here. 90.9 grams of O2 goes in this part. I'm going to take my unit and drag it down. I include the unit and the substance. I'm trying to get to moles. I know how many moles O2 are in a gram O2, so that can go right here. Once I've got my unit set up, I can plug in numbers. 1 mole has a mass of 32 grams of oxygen. So I put 1 with mole O2 and 32 with grams of O2. Grams O2 cancels because it's on the top and the bottom. I'm left with moles O2. That's the unit I want, so this is set up correctly. I'm going to take my numbers and do the top number times the top number divided by the bottom. 90.9 times 1 divided by 32 equals 2.84, so I can enter 2.84 moles for my answer. For this question, it says a sample of O2 gas occupies 17.1 liters at 1.4 atm. The temperature is 327 Kelvin. What is the mass of the oxygen gas? Well, let's see what we have given. We know there's 17.1 liters, 1.40 atm, and it's 327 K. Liters tells me that's volume. Atm is pressure. K is temperature. My conditions are not changing, so I'll probably use the ideal gas law. So I also know that R, the gas constant, equals 0.0821 liter atmosphere per Kelvin mole. My pressure is in atmospheres as the unit, so I use this number for R. Now I'm looking for the mass, but mass is not part of the ideal gas law equation. Here's the thing. I can find N, which is moles, first, then convert to mass. So I'm going to use the equation PV equals nRT. I'm going to plug everything in. I'm going to multiply 1.4 times 17.1 and 0.0821 times 327. That'll give me 23.94 equals N times 26.85. To get N by itself, divide by the guy who's next to it. So divide both sides by 26.85. And N is equal to 0.8916 moles. But I'm looking for the mass. So I'm going to take my number of moles. I'm going to convert it to grams by plugging it in here. I take my given 0.8916 moles and put it here. And that's of O2. Drag down moles O2 and go to grams O2. We already found out the number of grams in a mole of oxygen in the last problem. If you look on the periodic table, take 2 oxygens, add them up, we get 32 grams in 1 mole. Moles is on the top and the bottom, so it cancels. We do this number times this, divide by this. So top times top, divide by bottom. 0.8916 times 32 divided by 1 equals, we get 28.5, That's grams, because that's the unit we didn't cancel. And you can put your answer in the answer